Welcome to the Wild Side on Source 96.1 FM. I am your host, Kight, and that was Emmylou Harris singing Jupiter Rising. And today, if you are listening, you'll remember I am going to be moving on from the inner part of our solar system to the outer part of our solar system and finishing up the 3-week-long trio of shows I've been doing about our solar system. Now, the first planet that makes up the outer solar system is Jupiter, and I'm spending quite a lot more time on Jupiter today than I am on the other planets that are out beyond it, because Jupiter is, in fact, quite an interesting thing. And a lot of the planets that are in the outer part of our solar system have a lot of things in common. And so I'll kind of discuss them now and then just kind of gloss over them a bit when I get to those planets that share those same characteristics later on. But one of the reasons that Jupiter is such an impressive and interesting thing is that in addition to being the 5th planet from the Sun, it is also the largest. And it is so massive that it has more than twice the mass of all the other planets combined. And if you want to put it in Earth terms, it's over 300 times the mass of the Earth alone. Now, the name of Jupiter does reflect this kind of lofty status, because Jupiter was the king of all of the gods in Roman mythology. So, another kind of interesting thing about its size is that it's just about as large in terms of diameter as a gas planet can ever manage to be. So, at this size, if you were to add in more material, you would just have compression as a result of gravity. And that means that you wouldn't have much change in the overall radius. So it really is kind of at the maximum of what a planet with its composition can ever hope to achieve. And it's also the 4th brightest object in the sky. It was previously thought to be a wandering star, a really big wandering star, but this view finally ended when Galileo was able to view it through a telescope in 1610. And when he did this, he also discovered 4 moons, which are now called the Galilean moons. And there are lots of others, which I'll mention later on. But this was one of the many amazing things that Galileo found in 1610 when he was exploring astronomy and kind of thinking a bit about how all of his findings fit in with Copernicus's theory about heliocentricity. And in fact, because Galileo saw the moons of Jupiter, this was one of the many things that did convince him that Copernicus was correct, because this was the first time that anyone had seen this sort of orbiting motion not centered around the Earth. So we knew, of course, that our moon went around us, and lots of people at that time were arguing that the Sun was going around us as well. But when Galileo saw the moons going around Jupiter, he knew for sure that there was at least one other body in the solar system that had things orbiting it, and that had nothing to do with our planet at all. And this suggested to him that there in fact might be lots of things that were orbiting independent of our planet, and that in fact our planet might be orbiting itself. Now, Jupiter is the first, as I've said, of the gas planets. So on the inner part of the solar system, before the asteroid belt, you've got the terrestrial planets, and now that we've gone through the asteroid belt, we're going out to the outer part of the solar system, and you've got all of the gaseous planets. And these, of course, as the name suggests, do not have solid surfaces. Now, the gaseous material gets denser with depth, and so you do have kind of the sort of change that we see where things are very dense and then they get a bit lighter as you go out. But in this case, we're looking at gas instead of physical stuff. Gas is physical, isn't it? But solid stuff. What we see when we look at these planets, so when we look at the smaller ones on the inside, what we tend to see is the surface, and maybe in some cases a bit of atmosphere. But with these guys, we're definitely seeing atmosphere. We're seeing the tops of the clouds that are revolving in the atmosphere around them. And I do say revolving, and I'll talk about this a bit more in detail in the future, because they do have a lot of wind that makes the atmosphere constantly stay in motion. Jupiter is approximately 90% hydrogen and 10% helium in terms of numbers of atoms, but there are also bits of methane and water, ammonia, and rock mixed in. And in fact, the composition of Jupiter, I'm mentioning all these specifics that might sound kind of boring, but I say that because it's very similar to the composition, or the expected composition, of the nebula from which our solar system was formed. So this is quite an interesting thing to look at Jupiter and basically kind of see a planet-shaped version of that nebula that gave birth to our entire solar system. Our understanding of Jupiter's interior is quite indirect because the spacecraft that we sent out to explore Jupiter could only probe approximately 150 kilometers beneath the cloud tops. And given how vast Jupiter is, that is really just a tiny, tiny fraction of the total amount of space that is there to be studied. So what we guess is that it probably has a core of heavy rocky material, and above this core we have the main bulk of the planet. So that core would be buried, of course, right in the middle, way far below all the other stuff that's on the outside. So on outside of that tiny core, you're going to have lots of probably liquid metallic hydrogen, and this is quite an exotic form of hydrogen that's found only at extremely high temperatures. And that's another thing that makes Jupiter quite interesting and kind of exciting. And this metallic form of hydrogen can conduct electricity and is the source of the planet's magnetic field. And it's actually a really impressive magnetic field. It is incredibly huge. It extends more than 650 million kilometers and goes out so far that it goes past the orbit of Saturn. And this area contains high levels of really energetic particles, and these would be immediately fatal to an unprotected human being. And this is kind of an interesting thing because we do always have these hopes of going out into outer space, maybe colonizing another planet, maybe visiting another planet. But this just goes to show that, there are lots of really dangerous things out there in space, and a lot of them we can't even see. Now, another interesting thing about Jupiter is that its layer may also contain some helium and some ice. So even though it does have all this activity going on in this metallic stuff, it does also have some other elements as well, and even ice. Potentially, probably not water in ice form, but other gases and liquids that have been turned into ice. The outermost layer of the planet is mostly molecular hydrogen and helium, again, with liquid at the inside and then becoming more gaseous farther out, so depending on kind of the temperature and the pressure and the local conditions. Now the clouds themselves are found in 3 different layers. You're going to have an ammonia ice layer, an ammonium hydrosulfide layer, and a mixture of ice and water. None of which, except maybe that last one, sounds very enticing for a visitor. The Galileo atmospheric probe that was sent out to look at Jupiter found some really surprising information when it started taking all of these measurements from the atmosphere. What it found was that there was much less water than we had originally suspected that there might be. The temperature was much higher, and also the density was much higher. However, it should be said that some people have now begun to think that maybe we sent the probe, well, it didn't have to do with when we sent the probe, but when the probe arrived, the conditions there were actually kind of at a bit of a peak, so it was a bit different than it normally tends to be on average, and so they happened to collect some measurements that don't necessarily represent what Jupiter is like most of the time. But it could also be true that the kind of theoretical calculations that we made were just not accurate because we know so very little about this planet and are kind of basing these calculations on some guesswork. So obviously a bit of more future research is needed to really understand more about the planet. Now, as I kind of referred to earlier, Jupiter does have lots of really high velocity winds, and these occur latitudinally in bands, and you can actually have the winds blowing at different directions in different bands. And the speeds go up to 400 miles an hour and may extend down for thousands of kilometers into the interior. So this is not just something that's happening at the top of the atmosphere where we can see it, but it goes way down into the planet as well. Because of differences in chemical composition and also in temperature in these kind of localized areas where the bands occur, we can see them as distinct from one another. And this, of course, is probably one of the most characteristic things of Jupiter outside of its size, is that we know that it has these nice kind of orangey, whitey, reddy kind of bands. And the light-colored bands are referred to as zones, and the dark-colored bands are referred to as belts. And the colors probably result from chemical reactions that occur between the trace elements that are found in the atmosphere. So at the lowest altitudes you'll have kind of a bluish hue, in the middle you'll have browns and whites, and then at the highest, so the bit closest to space, you'll have reds. And sometimes, for instance, the blue you don't tend to see that often. If you ever look at a picture of Jupiter, it tends to be kind of reddish and yellowish and orange, as I said earlier. But there is blue down beneath, and sometimes you get holes in the lower layers, and that allows you to, holes in the higher layers that allow you to see down through to the lower layers. And so every now and then, as these winds shift and as the weather changes, you might be able to see a bit of blue on Jupiter's surface. Well, surface as much as Jupiter has one, given that it's a gas planet. In between the boundaries of these different bands, you'll have really intense vortices where the winds are interacting with each other. And as you'd expect, these are particularly intense where the bands are going at cross directions to each other. And all of this turbulence suggests that there's something going on, not from the exterior heat from the sun, but actually from the planet itself. And I couldn't tell you exactly how it is that researchers decided this, but something about the way that the winds move suggested to them that it's not a result of solar heat, but from something within Jupiter itself. And in fact, Jupiter does radiate more energy into space than it receives from the sun, and the temperature of its interior probably goes up to something like 20,000 Kelvin. So it is, of course, a very, very hot place, and that would certainly provide enough energy to kind of fuel these sorts of winds. Now, another one of the really famous things about Jupiter is that it has something called the Great Red Spot, or the GRS. And this has been observed for over 300 years, because even with rudimentary telescopes, it was something that was quite visible. The oval shape of the Great Red Spot covers about 12,000 by 25,000 kilometers, which is pretty massive. In fact, it's big enough to hold at least 2 or 3 Earths. There are other similar but much smaller spots that are also present, so this is kind of a thing that happens on Jupiter, is that these spots form. And what they seem to be are high-pressure regions where the cloud tops are higher and also colder than in surrounding areas. And like I said, the bits that are farthest out towards space tend to be the reddest, and that's why you have this kind of red hue of these high-altitude areas. And it's very poorly understood how and why these structures form and then persist over time. Now, Jupiter also has some rings, and this is something that actually we didn't know until fairly recently in the history of astronomy. They're very small, and they're very faint, and they're very dark. So they're very unlike the rings of Saturn and the other planets that we are aware of that have rings. And they also contain no ice, like those of Saturn. And the rings are probably continuously turning over because they're resupplied by dust that sprays up when meteors will hit Jupiter's inner moons. So some of the dust will eventually go away and maybe be hit off course by things that pass through, maybe crash somewhere, and then it's resupplied by other dust that's sprayed up into the atmosphere as things, not the atmosphere, outside of the atmosphere, as things interact with Jupiter and also with the bodies around Jupiter. Now, I mentioned that Jupiter has moons. I mentioned the 4 Galilean moons, which are the largest ones that Galileo was able to see, but there are also 59 other known satellites, and because there's so many, and some of them are quite small, they've not even been named yet. And the planet, along with the Galilean moons, can actually be seen with binoculars, so you don't have to have any fancy equipment if you want to go out and see Jupiter. But if you do have a telescope, then you'll be able to resolve not just the planet itself, but also some of the bands and also the Great Red Spot. And that was Deb Talan singing Saturn's Light. And you are listening to The Wild Side on Source 96.1 FM. I am your host, Caitlin Kight, and today I am talking about the outer planets in our solar system. And the next one up on my list is Saturn, which is the 6th planet from the Sun and the 2nd largest. Now, Saturn is named after the Roman god of agriculture and is also the root word of our word Saturday. And it's been known since prehistoric times, but was not observed through a telescope until Galileo saw it in 1610, when he made all sorts of interesting observations in support of Copernicus's theory that the sun was at the center of our solar system and not the Earth. Now, when Galileo saw Saturn, he was quite confused by its unusual appearance. And this probably is because, at that time, Earth was passing through the plane of Saturn's rings, and this happens every few years. And this can drastically alter the planet's appearance and make it look quite unusual. And at that time, people didn't know that some of the planets had rings around them, and so Galileo would have been expecting a nice, kind of ball, spherical shape up there in the sky, and instead he saw something with these little bits off to one side or another. Now Saturn, not only does it have these rings that are quite famous, but it's also what's called oblate, which means that it's flattened. So the whole planet itself is also kind of smushed in a little bit. And its equatorial and polar diameters actually differ by almost 10%. This is caused by the fact that Saturn does rotate very rapidly, and also because it has a fluid state, and so that all the stuff that makes it up, it can move around and be shaped as it's moving quickly through the sky, and you wind up with this kind of, again, not to be sporty today, but the kind of rugby ball type shape that I mentioned when I was talking about some of the inner planets as well. Now Saturn is the least dense of all of the planets. However, its composition is similar to that of Jupiter, and therefore it's also very similar to that primordial solar nebula that gave birth to our solar system. So again, it's another interesting planet to study, because in some respects it's like looking back in time a little bit. Also, like having a similar composition to Jupiter, it also has a similar structure to that of Jupiter, and like Jupiter, radiates more heat than it receives. However, this is not the reason why Saturn is really bright, so it may be part of the reason, but there's something else going on that makes Saturn be as intensely bright as it is. And because Saturn is very bright, that means also that its rings are very bright, which is why it's the planet that's most famous for having rings, even though all of the exterior planets, the four that are outside of the asteroid belt, also have their own rings. And scientists think that potentially it's so bright because it has helium from the interior that leaks out, but this is really not very well understood. Now, the bands of Saturn are quite interesting because they are very, very prominent, much more prominent, as I said, than the other ones. It also has bands like Jupiter. Saturn does also have some faint bands, like the ones that are observed on Jupiter, but they're not very prominent. What is more prominent, as I mentioned, is the rings that Saturn has, and it has 3 that can be seen from Earth, and then 4 others that have been seen by spacecraft. Now the ones that have been observed from here are very wittily known as A, B, and C. And A and B are quite a bit more obvious, and C is much more faint. And the gap, the very noticeable gap between A and B, is known as the Cassini division. Now, as I mentioned, there were an additional 4 kind of faint rings that were observed once we sent a spacecraft out to get a bit closer to Saturn. And all of these rings are much brighter than those of the other planets, even though there are some that are quite a bit fainter than the others just around Saturn itself. The rings themselves are composed of lots of small particles that each have their own orbit around the planet. So when we look at the rings from here, or when we see a picture of them, they seem to be this nice solid body. But in fact, if you were to go up much closer, you'd see that there are tons of little things. Some of them very small, so something like a centimeter long. Some of them very big, so you might have several meters, or even a few that are over a kilometer. And all of these things are kind of just holding their own trajectory around Saturn, and they kind of are there together in those ring shapes because of the nature of the gravitational pull around the planet, and also the kind of counterpull, if you will, of the things that are around Saturn as well. And most of these particles are water ice, but some of them may also be rocks that have an icy coating around them. Now, images of the rings show some really unusual structures that you can see up close, and these have not yet been explained. So they appear to have kind of little twists or gaps or kind of bulges, all sorts of strange structures in the rings. And these might represent mini-moons that we just can't see very well because the resolution is not good enough on the photographs. There might be interactions with Saturn's magnetic field, so it's kind of putting some of the particles in different orbits than they might ordinarily have. no one really knows yet. And there are lots of cool images of these online, and I'll try to link them up to the website whenever I update it so that you can see those. Because when you see them up close, you really do see that these aren't just solid rings that are floating around the planet. You really get a sense of the character of each of the rings, and you can see all the little tiny subtle variations that occur within them. Some of Saturn's moons, and it does have several moons, seem to play an important role in shepherding the rings and keeping them in place. So when I say several, I mean maybe 53 or so satellites. 53 is the number that's there now, but these things are always kind of being reclassified, and new things are being found, so there might be more or less at any given moment. But all of these planets, all of these moons outside the planet do kind of offer a balance between the pull of Saturn and the pull of the moons, and that's one of the things that can help keep all these particles in line in a ring around Saturn. Now, although you don't often hear people talking about seeing Saturn in the night sky, you can actually see it with the naked eye. But if you use a telescope, you can not only see the planet, but also its rings and some of its larger satellites. And I was lucky enough to actually see Saturn when I was taking an astronomy course. And it was amazing because we were looking through the telescope and it just looked fake, really, because I was so excited to see this planet that I'd never seen before, and I looked through and it just looked like someone had taken this tiny little piece of white paper that was shaped like a planet and stuck it on the end of the telescope. And I think that was because the telescope wasn't really high resolution. But it was amazing. You could actually see the rings and you could see the planet, but it just looked like a little plastic decoration instead of the real thing. All the same, it was really incredible to know that I was looking at this massive planet that's really far away from the Earth, and it was the first and only time, actually, that I've ever seen rings around a planet. So if you get the chance to pull out your own telescope or go use someone else's, I definitely recommend it, because it's really neat to see a planet that's very visibly different from all of the other ones around it. And that was Luminescent Orchestrii singing Neptune's Daughter. And contrary to that title, the next planet up on the list is not Neptune, but it's Uranus. I just couldn't find a song that dealt with Uranus, which is probably not surprising. So Uranus is the 7th planet from the Sun, and it's the 3rd largest by diameter, but not by mass, because there is a bit of a rivalry between Uranus and Neptune. Now it's named for the ancient Greek name for the supreme god, which is kind of funny when you think about the fact that Jupiter is the biggest, but why quibble? So Uranus didn't actually come into being as what we call it today until 1850, because it had previously been named for its discoverer or for his patron, who was King George. And so there were a couple of different names that were used for the planet until 1850, when people decided that they needed to get it in line with all the other kind of mythology-based names in the solar system, and so they did decide to go ahead and use Uranus. It was the first planet that was discovered in modern times, and that happened in 1781 by William Herschel. And he saw this through his telescope, just like others before him had seen it through their telescopes, but they thought that it was a star, and he was the first one to recognize that actually it was a planet, and that's why he is credited with the discovery. Most of the other planets have axes that are nearly perpendicular to the plane of the ecliptic, which is the plane that most of the planets tend to kind of, on average, orbit around the Sun in. But Uranus is a bit different because it has an axis that's almost parallel to the ecliptic. So this makes it kind of interesting and unusual. And this strange tilt results in poles that actually have more solar energy than the equator. And so we, of course, have lots of energy going straight to the equator and not at the poles, but Uranus is the opposite. But despite this, Uranus actually has a hotter equator than either of its two poles. And the reason for this is still a mystery, but potentially has something to do with something that's going on inside of the planet itself. It's composed mostly of rock and also ices, and it has about 15% hydrogen and a little bit of helium as well. And both Uranus and Neptune are similar in many ways to the cores of Jupiter and Saturn. But Uranus itself doesn't actually have a real core. Instead, it has a uniform distribution of all of its material, which is quite unusual. So when I say that it's similar in many ways to the cores, what I really mean is the composition of those cores of Jupiter and Saturn. The structure and this uniform distribution, of course, is quite different. Now, like those other gas giants, Uranus has bands of fast-moving clouds, but they're very faint. So kind of like Saturn, it does have those bands, but they're not really obvious in the way that the ones on Jupiter are. And the level of activity of these bands varies according to season, which kind of makes sense if you think that potentially they are driven at least partly by the heat from the sun. And so as the planet is revolving on its axis and also revolving around the sun, you've got this interaction of rotation and orbit, and that could maybe influence what the level of activity is at these different parts of the atmosphere. Now, Uranus is quite a nice, pretty blue color, and that happens because the red light is absorbed by methane that's in the upper part of the atmosphere, and that leaves the blue stuff left over for us to see. And this is kind of amazing considering that methane only makes up about 2% of the entire atmosphere, and yet it has this very significant effect on the appearance of the planet. Now, under this overlayer of bluishness, there might actually be other bands of colors as well, as we see on some of the other planets, but we're not sure about that because we've never seen, or we're not sure if we've actually seen below it. In the same way I mentioned that Jupiter will sometimes have holes appear so that you can see below. This may or may not also happen on Uranus. And if there are other bands of colors, then they would theoretically emerge because of interactions of tiny trace chemicals, or even from the hydrogen and helium themselves that are found in the atmosphere. Now, Uranus has dark and faint rings. There are 13 of them that have been discovered so far, but there could actually be others. And the discovery of these rings came after we already knew that there were rings on Saturn. And this was quite an exciting thing because previously the rings of Saturn were the only ones that were known in our solar system, and so we all thought that Saturn was this very unusual and exciting thing. Not to say that, not to belittle it and say that it's not exciting, but in fact, once they found the rings around Uranus as well, you realize that actually rings are something that maybe happen on a regular basis in our solar system, and in fact that has since been found to be true because we do see that there are rings on all of the gas planets outside of the asteroid belt. Uranus also is in possession of 27 named moons, and also of note is the planet's magnetic field. And it's interesting because it's not actually centered around the planet itself, so most of the magnetic fields tend to be kind of, more or less centered on the planet. Instead, it's tilted about 60 degrees with respect to the axis of Uranus's rotation, and this is potentially caused by motion that occurs at shallow depths within the planet itself. But no one really knows. And so this is another one of these many astronomical mysteries that I've mentioned over the last couple of episodes that needs to be explored in a lot more detail. And of course, the number of mysteries that remain kind of increases as you go outward from the sun, because the farther away these things are, the harder they are for us to investigate. And this is one of the reasons that we've put out a lot of spacecraft that will eventually make their way to these outer planets and send back data for us. But until that time, we have to just kind of, use data that have to do with looking at the chemical composition of the planets and calculating things about their orbits and kind of the way that they move, and use that to infer data about what the planets are actually like in real life. So this is just one of many things that we'll need to know about Uranus and the other farther planets in our solar system. Now, unfortunately, this planet is actually very difficult to see. So if you know exactly where to look, if you have a really clear sky, if you've got very keen eyes, you might be able to see it with the unaided eye. But it's much better if you've got binoculars or a telescope. But even then, it's much easier if you know where to look, because it is quite a hard thing to locate. It's not very big, it's not very bright, so you would really need to have some good charts in order to find your way in the sky. That was Amy MacDonald singing The Furthest Star. And I'm not going to talk about the furthest star right now, but I am going to talk about the furthest planet, and that is Neptune. And Neptune is not only the 8th planet and the last one from the Sun, it's also the 4th largest by diameter. Though, as I mentioned earlier, there is a bit of give and take between Neptune and Uranus in terms of which is larger by diameter and which is larger by mass. Now Neptune is named after the Roman god of the sea, and it was discovered in kind of an interesting way because there were astronomers who observed by astronomers who noticed that the orbit of Uranus was not what it should have been given Newtonian laws. And so they expected that perhaps its orbit was being pulled out of position because there was a planet out there that was affecting it. And if they knew about this planet and could calculate, where it might be given what they observed Jupiter and Saturn and Uranus doing, that potentially they would then be able to actually spot it in the sky. And in fact, this is exactly what happened. So in 1846, there were a couple of researchers who independently found the planet of Neptune after they were given these calculations by a couple of other guys who did all the heavy mathematical lifting. But what's really interesting about this is that the predictions were actually inaccurate. They were kind of accurate more or less over the short term, but they would have gotten increasingly inaccurate over time because this was calculating, where the planets should be as these other planets were orbiting around in space. And of course the orbit takes place over many days and years. And so they were able to find it right away, which is good, because if they'd waited just a few more months, few more years, the planets would actually, the planet would have been much further away from where it actually was discovered. And so people probably would not have found it except by extreme luck and chance. So as luck would have it, it was in fact found, and it was found by a Frenchman and an Englishman, and so this caused a lot of international controversy because both of the countries wanted to claim this success as their own, although apparently the scientists themselves weren't too ruffled about this, but it certainly became an international issue, and now everyone involved, both of the mathematicians and both of the astronomers, are credited with finding the planet, the last planet in our list. Now, Neptune is known for having quite an eccentric orbit, and its orbit is so strange that it occasionally crosses the orbit of Uranus, and the two reverse their positions relative to the Sun. However, its composition is quite similar to that of Uranus, and so it also has a very similar color, and so they are in many ways quite a lot alike. However, the blue of Neptune is much more striking than the blue of Uranus, and this is probably because there's something else in the atmosphere that is adding to the color. The blue of Uranus is kind of a greeny sort of blue, but this one's a much more vibrant, totally turquoisey kind of blue itself. Now the winds of Neptune are also of note because they are in fact the fastest of the solar system. And I've mentioned a couple now that have very fast winds, and I've said 350, 400 kilometers an hour, but Neptune really blows them out of the water because its winds reach about 2,000 kilometers an hour, so it's incredibly intense. And like some of the other planets out in the outer solar system, it radiates more energy than it receives from the Sun. So it has an internal heat source, and in fact it radiates about 2 times the amount of the energy that it receives from the Sun. So it's a very hot planet. And like Jupiter, it once had a notable spot that was known as the Great Dark Spot. And this was about half the size of Jupiter's, but still quite large. It was the same diameter as the Earth, so it's a very big thing. And it was of quite a lot of interest, and it was observed by some of the spacecraft that were sent out to take pictures of our solar system, and then suddenly it was gone. And researchers were quite flummoxed because it had been there for quite a time. It was a very interesting thing that had been well studied. And then not too long afterwards, they found another one that reappeared. Or I should say appeared. It's probably not the same one. It's a whole other different one. But this kind of fluctuation of the atmosphere suggests that there's quite a lot of change that happens, which is probably to be expected given how fast the winds move on this planet. Now, Neptune also has a small little cloud that spins around the planet every 16 hours or so, so it's moving very rapidly. And this one is known as the scooter because of the speed with which it goes around the planet. And the origins of the scooter are not very clear. It potentially is a plume that has risen up from the lower atmosphere and then been kind of sucked into that upper layer that we can then see as it moves around the planet. But altogether, it does have quite a lot of interesting stuff happening on Neptune and looking quite interesting to astronomers who are able to view it. Neptune does also have several rings, like the other planets out in this part of the solar system. At first, they were thought to merely be arcs, so incomplete rings, basically. And then once we got close enough to take pictures, we found out that actually they are rings that are in entirety, but they just have little tiny sparse bits in between these more major, obvious arcs. And the composition of these rings is not yet known, but they have all been named. And they are named Adams, Galatea, Leverrier, and Gal, or Galle, I'm not sure, Galle. Neptune also has 13 moons, and although this planet can be seen through binoculars, you really need to know where to look. Again, we're kind of on a very small scale, and there's lots of other stuff in the sky, and it would be quite hard to really pinpoint it accurately. And if you want to see any sort of detail, you would definitely need a telescope. Now, the last thing on my list to talk about today is the dwarf planets, and this is important to bring up because the dwarf planets are a group that include Pluto, and Pluto, of course, was once a planet. For a lot of you, Pluto was the 9th planet, and it was quite a wrenching experience to suddenly have that name change and have it demoted. It was quite strange to me because I grew up, learning about the solar system in a particular way. You learn that mnemonic device for remembering the order of the planets, and suddenly you've got one of those chopped off, and it's a very strange thing. And it was, in fact, very controversial. And this was a ruling that was made a few years ago now, because researchers already knew about several other dwarf planets in the system, and they were saying, look, Pluto has lots of things in common with these dwarf planets. There are lots of things it doesn't have in common with the planets, and so it really makes sense to group it in with these other dwarfs. And so, in brief, really, a dwarf planet is something that looks like a planet, but it's not big enough to be one. And if you really want the scientific description, there are 4 things that it has to satisfy. So, the dwarf planet has to be in orbit around the Sun, which of course Pluto is. It has to have sufficient mass so that its self-gravity will overcome rigid body forces so that it assumes a hydrostatic equilibrium, or in other words, a nearly round shape. It also has to have not cleared the neighborhood around its orbit, and it's not a satellite. So basically, it does look and seem to us like a planet, but it doesn't quite get to that because it's just not quite large enough. And I think in the case of Pluto, one of the clear things is the issue of clearing the neighborhood around the orbit, because you do have to have quite a lot of size in order to be able to achieve this, because your gravity would scatter things off or suck them in, if I'm not mistaken. Now, other than Pluto, the other dwarf planets include Ceres, Eris, Makemake, and Haumea. And unfortunately, I couldn't find out much about Makemake and Haumea, and so rather than go through each one of these, I've decided to just kind of stay focused on Pluto and kind of maybe a bit of acknowledgement of the fact that it once was a planet, even if it has been demoted. So I'll talk about it in a bit more detail. And actually, before I kind of move specifically into Pluto, I should note that it's highly likely that more dwarf planets will be added to this list as we explore the Kuiper belt in further detail and are able to see the bits of the Kuiper belt more clearly. So Pluto, of course, once was a planet. It was actually smaller than 7 of the solar system's moons, which is maybe a good sign that it should have been demoted. It's named after the Roman god of the underworld, and some people suggest that potentially this name was chosen because the god of the underworld would have been in perpetual darkness, and Pluto is, of course, very far from the sun. That said, it's also not always the farthest planet out, planet or dwarf planet, because it also has a very eccentric orbit, and so sometimes it passes inside of Neptune and is a bit closer to the sun. Although sometimes, if you look at pictures of this, it might seem as though the 2 planets will collide. That's never going to be the case because they have orbits that have different inclinations. So even though one will kind of physically move closer to the Sun than the other, they're not actually passing each other in any close proximity. Pluto was actually discovered on accident. There were some erroneous calculations that were based on wrong information about the mass of Neptune. So given this incorrect mass, people predicted what Neptune's orbit should have been and discovered that, in fact, it was not following this orbit. The discovery of Pluto was actually a bit of a serendipitous event, kind of an accident, really, because there were some erroneous calculations that were made after people looked at Neptune's orbit and calculated what they thought it should be and what it actually was. And these two things didn't match up because they were using an incorrect estimation of Neptune's mass. And we now know that Neptune's mass is something completely different, and so we would expect its orbit to be what in fact it is. But at that time they thought maybe there's another planet out there that's moving Neptune in a way that is causing it to have this kind of unusual orbit. And so researchers were looking for Planet X. And in looking for Planet X, they went out and did a very careful survey and found Pluto. And only later was it found that actually Neptune's mass was wrong all along, but serendipitously here we had this extra planet that we suddenly now know about. And actually we do know that Planet X does not and never did and never will exist, but there are lots of other interesting and large objects beyond Neptune that are definitely still worth study, as I mentioned before in this first of the 3 episodes on astronomy. Pluto has never been visited by a spacecraft because it is so far away, but the New Horizons spacecraft, which was launched in 2006, should reach the planet by 2015. So definitely within our lifetime, unless something goes wrong, we should start to get some data back that will allow us to understand Pluto in a bit more detail. Now it has a really big moon, relatively speaking, named Charon, and also has 2 tiny moons that are named Nix and Hydra. And these have been kind of interesting and useful because they allow us to measure a bit more about Pluto. So Pluto and Charon together, we're able to measure their mass as a whole, but looking at one of them versus the other is quite hard to do, and that's just because they're both so small and so far away that it's hard to get much resolution. But because the 2 of them together are enough to measure, that gives us at least something to begin to work with. Another thing that's not really well known about Pluto is the radius, and what we do know is that it's actually a very cold planet, as you might expect. It's so far away. So it's anywhere from -235 to -210, and it's a planet of rock and ice, which really is not that, it's not that much to be excited about, because these are things you would kind of just guess off the top of your head knowing about where Pluto is located. But the kind of interesting thing about the planet, or dwarf planet, is that it's very similar to Neptune's moon Triton. And so some people suggest that maybe Triton and Pluto and also Charon may have all had similar origins. So they probably didn't break off of something else, but maybe they were all from the same place and were then sucked in closer, maybe from one of those outer belts. They were sucked into the more interior portion of the solar system and then became the bodies that we see now. So Pluto as a dwarf planet and the other 2 as moons. And of course all this is just conjecture and needs to be investigated in more detail, but that is still quite an interesting thing to think about. So on that note, on one of the many mysteries and questions that I've raised, I'm going to end my trio on astronomy, and hopefully you all have found this as interesting as I have. I've always loved astronomy, definitely not by any means an astronomer, but I do love the topic and I love reading about it, and I certainly love going out and looking at constellations. And if anyone, as I said before, has heard me say something incorrect, please do let me know. This is not my area of expertise, and I would love to know the correct information and also post it on the website or on the Facebook page in order to get the right information out there and to cover up my mistakes so that no one else goes and repeats them in the future. So for now, that is it. And again, I'm away in Kenya as we speak, but I will be back in a couple of days, and I will be live next week, and I look forward to that. So I will talk to you then.